Now we can see that our approximation isn't terribly accurate because there are all these gaps. There are these gaps that aren't covered by our rectangles, and these gaps are our error. So what could we do to potentially make this more accurate? Well, we could use more rectangles. So let's try that. Let's do a third approximation where we use 8 rectangles. So now we're going to have 8 rectangles. Well, we can go ahead and look at the width here. So I have a length, I'm going from 0 to 2, so I have a width of 2 minus 0, and I'm going to be chopping that up into 8 equally sized pieces. So the width of each of these will be 0.25. So I'm going to go ahead and chop this. 8 pieces, each of them 0.25. Let's just see what that would look like. So I'm going to take the left end point and look at the curve there to give me the height. And so this is my areas of these rectangles. You'll notice I have a smaller gaps here, the rectangle. So now my first rectangle is still going to be a width of 0.25, and the left endpoint is going to be 0 squared. So the area of the first rectangle is 0. Now when I go to the second, the width is still going to be 0.25, and I'm going to be taking the left endpoint of this 0.25 to 0.5 interval. So now I'm going to be looking at 0.25 times 0.25 squared. The third rectangle will be 0.25, have an area of 0.25 times 0.5 squared. The fourth rectangle will have an area of 0.25 times 0.75 squared. The fifth rectangle will have an area of 0.25 times 1 squared. The sixth rectangle will have an area of 0.25 times 1.25 squared. The seventh rectangle will have an area of 0.25 times 1.5 squared. And last rectangle will have an area of 0.25 times 1.75 squared. Now I just need to add all of these numbers up. And when I do that, that will give me the approximation. So I'm going to be adding up the areas of all of these different rectangles, add them together, and that gives me the approximation. To do that, I have 0.25 times 0 squared plus 0.25 times 0.25 squared plus 0.25 times 0.5 squared plus 0.25 times 0.75 squared plus 0.25 1 squared plus 0.25 times squared plus 0.25 times 1.5 squared plus 0.25 times 1.75 squared. And I get that the approximation here is 2.1875. Now that was my approximation using 8 rectangles with a left-hand rule. The number of rules we use is up to us. Also, the rule that we use to find the height of the rectangle is up to us. So let's look at one more version of this. What would it look like if we used, there's nothing that said we had to use the left endpoint to get our height. We could have used the right endpoint to get our height, and that would have been really cool too. So let's look at that. Let's look at still the same approximation of this same region of the curve y equals x squared from x equals 0 to x equals 2. And we're trying to get an approximation of this area in blue. We're going to use 4 rectangles again, but this time we'll use the right hand rule, which means that when we chop this up into 4 pieces, so 1, 2, 3, have 4 pieces now. I'm going to be taking the height of the rectangle from the right endpoint function value. So when I sketch out these rectangles, it would look like this. Notice this is an overestimate instead of an underestimate. So we're going to be getting too much area here, but that's okay. That's something we're willing to accept. So with a right-hand rule here, notice the width of each rectangle is still going to be 0.5. So for all 5 of these, or all 4 of these, the width is 0.5. Where am I getting that? I'm getting that because my length of my interval went from 0 to 2. So the width is going to be the length of the interval, which is 2 minus 0, divided by the number of pieces, which gives me 0.5. Then I'm looking at the height of the right endpoint of the function. Okay, so the right endpoint for this interval is 0.5. So f of 0.5 would be 0.5 squared. Then for the second one that goes from 0.5 to 1, the height would be f of 1, which is 1 squared. The next right endpoint is 1.5. So that height for this rectangle will be f of 1.5, which is 1.5 squared. And finally, for the last one, we have f of 2, which is 2 squared. So I'm multiplying the width times the height to get all of these areas. And so I get all these multiplies and add them all up. So the area of my approximation would be 0.5 times 0.5 squared plus 0.5 times 1 squared plus 0.5 times 1.5 squared plus 0.5 times 2 squared. And if I calculate that out, I get 0.5 times 0.5 squared plus 0.5 times 1 squared plus 0.5 times 0.5 times 2 squared. And my approximation there would be 3.75. So when I do an approximation with rectangles, I have to make a decision. I have to decide how many rectangles I'm going to use. And if I'm going to use the left or the right hand method to get my height of my rectangle.